Hello everyone. Today I am here to show you a prototype of Bluetooth communication. I am gonna control this LED using my Android mobile via Bluetooth communication. The circuitry is very simple. I have used an Atmega 328P microcontroller over here. So this will be communicating with my Bluetooth module HC05 through UART communication, serial communication. So the only thing you need to worry about while making communication using UART is the baud rate. Presently my HC05 Bluetooth module is configured with a baud rate of 38,400 bits per second. So my one more important thing to be noted is that the I/O pins of HC05 are supposed to be operated at 3.3 volts level, but my microcontroller is going to give an output of 5 volts. So I am not connecting the TX of my microcontroller to the RX of HC05 directly. I'm stepping it down to 3.3 volts and then connecting the pin to the RX of HC05. Whereas TX of HC05 is directly connected to RX of my microcontroller, because 3.3 volts is identified as a level high with my microcontroller at Mega 328. So and don't worry about this Arduino. I've used this Arduino just to power up my circuitry with the 5 volts, both microcontroller and the HC05. That's all about the connections. So now let's get into the coding. Before getting into coding, let's just understand the registers of our microcontroller. I have used Atmega 328P microcontroller here. So for the UART communication to be established, there are certain things we will have to initialize. So as per the data sheet, setting of baud rate, setting frame format, and enabling the transmitter and receiver depending on the usage has to be done for the UART communication to be initialized. I'll discuss about baud rate later. First, let's discuss about frame format. The possible frame formats for our UART communication are, it starts with one start bit followed by 5 to 9 data bits, and then parity bit if needed can be configured to even or odd, and number of stop bits would be 1 or 2. So in our case, the frame format consists of 8 data bits, no parity bit, and then 1 stop bit. Now let's look into the registers for the configuration of this frame format. This is UART controller status register 0C. The first 2 bits, cell bits, these corresponds to mode of operation of UART communication. We are operating in asynchronous UART. So these bits should be set to 0. However, by default they are set to 0 and we don't have to worry about them. And next 2 bits, UBM 00 and 01, these corresponds to parity mode. We are however disabling it, so the configuration should be 00 for these 2 bits. By default they are configured to be 00, so we don't have to worry about these bits also. And next is the USB 0. It corresponds to the number of stop bits in our frame format. As said earlier, in our frame format we are using only 1 stop bit, so it has to be configured to 0, and this itself is the default setting. And next 2 bits corresponds to number of data bits. If you look into the details of it, as said earlier, number of data bits in our case is 8. So the configuration should be 0, 1, 1. Low significant 2 bits should be set to 1. And that itself is the default setting of UCS Z00 and 01. And how about 11? The most significant bit as in UART controlling status register 0B, and it is set to 0. So by default the frame format is set to the condition in which we want it to be. So now let's just discuss about baud rate. As per the data sheet, for a specific mode of operation, baud rate can be calculated. As per these formulas, baud rate can be calculated for each and every mode of operation. We are operating in asynchronous normal mode, and U2xn should be set to 0, and that itself is the default setting, so we don't have to worry about that too. And here is the formula for the baud rate. UBRR register value should be set to this value. Basically it's an integer value, so we should set the value as close as possible to this real number, and it might not match exactly with this value, and because of which there would be error, that is very significant. So F oscillation frequency, it is the system clock frequency would be used here, and then the baud rate in our case is 38.4 kbps. So what would be the possible values of our UBRR register? As per this, for oscillation frequency of 1 MHz, this is the default setting of our microcontroller, and 38.4 kbps as the baud rate. For the normal mode of operation, UBRR value should be 1, and this is associated with an error of -18.6, which is very high. In fact, I have tried this, it did not work for me. So you should look for configuration which gives you a minimum error. So I have changed the oscillation frequency. Basically the microcontroller uses 8 MHz internal RC oscillator, and it is programmed such that, clock div 8-bit is programmed so that prescaler value is set to a value of 8. So it divides the internal RC oscillator frequency, and finally 1 MHz will be the default frequency of oscillation. So now I am unprogramming that clock div 8-bit so that my system frequency would be 8 MHz, and if for the 8 MHz 38.4 kbps, the UBRR value that has to be set is 12, and for this configuration error percentage 0.2, which is very very less compared to that of previous value, and it worked perfectly fine for all the attempts I have made with this configuration. Now let's just get into coding. So this is our code. io.h header file is used here, and a variable UBRR value of data type integer is assigned with a value 12, as explained earlier. And the same value I am using it here for initialization. This is the function for initialization of UART. For setting the baud rate, this is what I have done. If you look into the data sheet, UART baud rate register, there are two registers here, UBRR0L and UBRR0H. It is of 12-bit value, and the most significant 4 bits are to be assigned to this register, and the next low significant 8 bits should be assigned to this register UBRR0L, and that is what I have been doing here, assigning right shifting it with 8 bits, and then assigning the value to UBRR0H, and UBRR0L is assigned with the 8 significant low bits, 8 low significant bits. We don't have to worry about frame format. The default settings match with our desired frame format configuration. And next comes enabling of transmission and reception. We are enabling both transmission and reception. However, in our case, only reception is needed, but I am also explaining the transmission part for which can be useful for other projects. So this is the function to send a byte through UART communication. In our case, it is UART. First thing that I am doing is I am checking whether the data register is empty or not. If it is empty, UDRE0 data register empty bit in the UCSR0A register would be set. If it is not empty, it remains 0. Basically, if it is performing some other transmission and it is busy, then it would be 0 and it would stay within the while loop as long as it is 0. Once the data register is empty, this bit would become 1 and the program control will come out of this loop. Next thing what we are doing is putting the data into the data register. Whatever data is being given as an argument for this function is put into the data register for the transmission to be done. So here is the function for receiving a byte, and this is important in our case. Here what I am doing is I am checking whether the reception is completed or not. If reception is completed, RxC0 bit in the UCSR0A register would be set. If not, it would be 0, and as long as it is 0, the execution lies within this while loop. And once it becomes 1, once the reception is completed, it would come out of this loop, and then whatever data is present in the data register would be written in the form of an 8-bit integer format. So now let's just look into the main code. This is our main code. First thing what I am doing here is declaring a variable U8 temp data of the type 8-bit integer, unsigned integer. So I will have to configure basically I am using pin 5 of port C, so I will have to configure it to be output by setting the corresponding bit in data direction register of port C. And next thing is initialization of port C. I am initializing pin C of port C. I am initializing pin 5 of port C register with 0. Next thing is initialization of UART communication using this function, and within our infinite while loop, whatever data I am receiving on the UART, I am storing it in the variable U8 temp data. And if the data is equal to 48 is nothing but ASCII value of 0. So if a character 0 is received, then pin 5 of port C would be cleared, LED would be switched off. Else if it is 49, basically if a character 1 is received, then pin 5 of port C would be set, basically the LED would be turned on. And for any other data received, it would not respond, the pin 5 value would remain unchanged. This process repeats infinitely within this while loop. Hope you understood. So now let's just test the circuit. All the connections are made and 5 volts and ground pin from my Arduino are powering up my circuit. And if you see the HC05, it's blinking continuously for every 500 milliseconds. It says that it is not yet connected to any device and is ready to be connected. Now I am using my Android mobile. Bluetooth is already turned on. Using this Bluetooth terminal app, I will be able to control the LED via Bluetooth. Presently it's not yet connected to any device. So let's just connect to our module. HC 2010, here it is. Connecting, yep, connected. Now if you see H05, it's not blinking continuously as earlier. It is blinking twice for every 2 seconds. It means that it is connected to a device. So as per the code, if you send 1, then LED should be turned on. If you send 0, it should be turned off. For any other input, it should remain unchanged. So as LED is turned off as of now, let's just turn it on. 1 and then send. Yep, it is turned on. Let's turn it off. 0. Yep, it's turned on. Let's try sending some random data. No, I sent D, but it is not responding. Again, let's just turn it on. I'm sending 1. Yeah, it is working. It is working. I'll send something else. It shouldn't work. Yes. And then 0 to finally turn it off again. Yeah, it's turned off.